Hello everyone, this is Phil from statisticsmentor.com. In this video, I'm going to give you a gentle introduction to the crosstabs, otherwise known as cross-tabulation, otherwise known as Chisquare test. Now, it's a test, so being a test, we've got to know what the null and alternative stroke experimental hypothesis is. The null is there is no association between two attributes. Another way of saying it is there is no association between two attributes. And yet another way of saying that is attributes, say A and B, are independent. Okay, so the words independent, no association, no relationship mean the same thing. And the alternative, or the experimental hypothesis, is there is a relationship, or they are dependent, those two attributes, or there is association, depending on the words you used for the null. The idea of association is similar to correlation. Recall with correlation we're looking to see if there is a relationship as well, but it's for quantitative variables. Crosstabs is for qualitative variables. Qualitative, we mean that the variable is either nominal or ordinal. Okay. Now in crosstabs, the basic crosstabs, you're seeing if there's a relationship or no relationship between two qualitative variables. Right. So these two qualitative variables may be either both nominal, both ordinal, or a mix. One is ordinal, one is nominal. Now this crosstabs is quite a common method that is employed when you're dealing with survey type data. Alright. Now I've got an example here. I'm trying to see if there's a relationship between smoking and lung cancer. Now suppose I have no idea that whether these variables are quantitative or qualitative. What kind of clue can I get from that? Well, if you go to variable view, smoke is whether the person smokes, yes or no. If we click on the values there, that's coded, smoker or non-smoker. If it's coded, something like this, then that means it's qualitative. In this case, it's nominal. Cancer is coded again. Yes, so again, this tells us it is qualitative. So if we were looking to see if there's a relationship between smoking and cancer, then correlation is not the appropriate method, but the test of association or crosstabs, this crosstabs analysis is. And then we look at, we've got another two variables here which we're not going to use today, but just to show you that age, you can see it's not coded, the value's there, there's nothing there. So that tells us that age is most likely to be quantitative. Those numbers actually mean something, they're not codes. Okay, well, I've only done the first few there for you. So in that case, if age was involved, then crosstabs would not be appropriate. But since our hypothesis, we're trying to test to see if there's a relationship between smoking and cancer, and both those are qualitative, crosstabs is the way. Okay, first of all, being an introduction, let's take things real slow. Let's first of all bring up the counts. So to do that, go to Analyze Descriptives, and we go to Crosstabs. We've got rows and columns. It doesn't matter really which one you put. Put one in rows, put one in columns. I put smoking in rows, put cancer in columns, and just then say OK. should give us a table of the counts. Alright, there's two tables. First one is not of interest, it's just telling us that we've got a sample of 100 people and no missing data there, it's all there. Okay, the next one, the crosstabs table. Alright. Reading it, we can see that smoking is split into two categories, smoker and non-smoker. And cancer is split into cancer and did not get cancer. And then we've got totals, the row totals and the column totals. So if we're to read this table, this tells us that this number here, 30, says that 30 people were smokers and had lung cancer. This number 5 here says that 5 people were smokers and did not get lung cancer. Hope you get the idea. Let's go down to this one. What does that say? That says that the 5 people were non-smokers and got lung cancer. And this one here, 60 people, non-smokers, did not get lung cancer. How many people? We know that there's 100 people. Out of 100 people, how many people altogether got lung cancer? 35, because you add up, this is the column of people got lung cancer, 30 plus 5 is 35, that's why this total is doing, it's totting up these column there. I really hate this double click to activate thing that keeps popping up in SPSS, it's very annoying. Right, how many people did not get lung cancer? 65. Okay. Similarly, how many people in my sample were smokers? Smokers, go to the column, row 30 plus 5, 35. And how many people out of my 100 were non-smokers? 65. In this row here, we add up 5, 60, 65. Alright, and then if you look at the sum of the total, that's 100, and the sum of the total there comes to 100, which is as it should be. Okay. Just looking at this, it gives us an idea that smokers tended to have more lung cancer and non-smokers. Okay. But because the total number of smokers and non-smokers are different, it's actually easy to make comparisons in percentage terms. So to do it in percentage terms, go to Analyze. Again, where is it? Descriptive Stats, Crosstabs. And now we click on Cells, Percentages. Let's get row, column, total. And OK. OK. Now a slightly bigger table, but you can see it's same as the first one because you still got the numbers there. Look, lung cancer smokers 30, 5, 60, those numbers are still there, but now we've got percentages. Right. So if we read along where it says 100 here, it means that's out of all people who smoke. Out of all people who smoke, 85.7% get lung cancer, and out of everyone who smokes, 14.3% do not get lung cancer, and those two percentages add up to 100. For non-smokers, within who smoke, comes to 100. So how is that 100 split up between lung cancer and no lung cancer? Well, out of non-smokers, 7.7% have lung cancer. That's 5, which is 5 out of 65, which is 7.7%, and 92.3% do not like lung cancer, who are people who are non-smokers. That's 60 divided by 65. That's 60 out of 65. I mean, is 92.3%. Okay, so now you can see the relationship is reversed. For smokers, they have a higher probability or higher chance of getting lung cancer. than non-smokers. Non-smokers, people who are non-smokers, the pattern is reversed. Most do not get lung cancer. Alright? So when we're saying is there a relationship between A and B, by relationship we're looking for a pattern. In this case it appears from our data that those people who do not smoke have less of a chance of getting lung cancer than those who did. Alright? Now, our analysis doesn't stop there. We haven't actually done any crosstabs at all yet, have we? Because we have not done a test. Well, now we're ready for the test. Because what we've done so far is we've looked to see if there's a relationship just by looking at the counts and the percentages. But these counts and percentages, this apparent pattern, what we've noted, could just be due to sampling error. Alright, so we need to test formally whether such a relationship holds, yes or no. If it doesn't, then the pattern that we've just looked at here is just due to randomness in the data. It's not actually there. So that's why we need to do the test. So now let's go ahead and do it. It's pretty much the same buttons again. Analyze descriptive stats, crosstabs. This time we click on statistics and we request the chi-square there. Let's say OK, and then we OK it. Now you see the first two tables are the same as what we've seen previously. There's an additional table, and this is the chi-square test table. Recall that the null is, well, you can chant it out to tell me what it is. Yes, the null is that there is no relationship between smoking and lung cancer. We read off the top one here, forget all the other ones. Pearson chi-square, the test statistic is 60.874, 1 degree of freedom, but to be honest that doesn't interest us. Those numbers, the test statistic and degree of freedom, ultimately to get the p-value, which comes under this what they call asymptotic significance, two-sided. Alright, right there, 0. Now recall that if the p-value is low, we reject the null, and the ditty to remember is if p is low, null must go. Now p is low, lower than 0.05, indeed it's lower even than 0.01. So what do? It's low, so the null must go, i.e. we reject the null in favour of the alternative. So we conclude that there is a relationship, there is evidence to support a relationship between smoking and lung cancer. And once we've done that, we can report it. We can report it like this in a report. There is very strong evidence of a relationship between smoking and death due to lung cancer, open bracket, and then write down the chi-square, comma, the degree of freedom, comma, the p-value less than 0.001. It's really tiny. Or you could replace there, if you're more comfortable, 0.05. Okay. So let's just look back at what we've done. Let's look at this chi-square. So this chi-square test is to test whether there's an association between two qualitative variables, which may be nominal or nominal or ordinal, or a mix of ordinal and nominal. We run the chi-square test and we look at the Pearson's chi-square, and the null is there is no relationship between the two things. Alright, if we do not reject the null, then the analysis stops and we say there is no evidence that there is a relationship between A and B, full stop, done. But if we reject the null, there is a relationship, and then we report what that relationship is by going to this table of counts and then looking and reporting the pattern like we did earlier. Okay, so that's the only time that this comes into play, is when we find there is evidence of a relationship. Now, what I want to make clear is, basically we're finished now, But I want to conclude by pointing out a few things, because this has been a very gentle introduction. There's obviously lots of things we've missed out, but for a first pass through this topic, it's sufficient what we've done. Right, now I get students saying that because the p-value here is less, it's very tiny, it's basically less than 0.001, that they say that there is a very strong relationship. There is a very strong relationship between smoking and death due to lung cancer. Now, why is that not correct? It's not correct because the lower the p-value, it does not mean the stronger the relationship. You know, this is only a test to see whether there's evidence of a relationship or there's no evidence, and if there's evidence, how strong is the degree of that evidence. And I think that's where students get caught out, especially if their first language is not English. So if the p-value is very low, it does not mean that there is very strong relationship. It means that there is very strong evidence of a relationship. Okay, so let's say that again. Low p-value means the lower the p-value, that means the stronger the evidence of a relationship. It does not mean the stronger the relationship. That's first thing. Second thing is that look under this chi-square test. It says here 0 cells, 0% have expected cell count of less than 5. Okay, now you will encounter occasionally, especially if you've got some categories with a few number of observations, that some of the expected cell values is less than 5. Now if that's the case, this chi-square approximation does not work so well, and then how you get around that is by collapsing groups. You might have heard about collapsing groups or combining groups. Okay, if you're still in the dark there, let's just run this thing but with the expected cell values and you'll see what I mean. So we'll go to analyze again, and let's see, where is it? Descriptive stats, crosstabs, and we want expected, not counts, we want expected. Now look at this table of counts that we've seen previously. We've also got under each cell now expected count. These expected counts are the kind of the theoretical numbers you would expect to see in the cell if the null was not true. If the null is true. So where this number 30 is, it says we observe 30 people who were smokers and had lung cancer. But if we expect there to be no relationship, if we expect the null to be true, we'd expect there to be actually around 12.3 people who are smokers and lung cancer. Why I say around is because obviously you cannot get 0.3 of a person. Alright, so the closer for each cell, the closer the count value to the expected count, that means the null is probably you probably will not reject the null, i.e. there is no relationship. Okay, because the expected counts are generated assuming that the null is true, i.e. that there is no relationship. Okay, now we swipe around here, 12.3, 22.8, 22.8, 42.3, all those expected counts I've just read out exceed 5, so we have no problem. Alright, but I'm saying that if we have tables where some of the numbers are less, the expected cell counts is less than 5, then we would have to think about collapsing cells if we can, because we can't always do it. Okay, next thing. Right, in terms of, so going back to the strength of relationship, we know that p-value cannot give you the strength of relationship, but if we find that there is a strength of relation, we want to, if there's a relationship, we can kind of report the relationships by doing what I did here very simply. But if you want to do it more sophisticated, you would use something called the odds and odds ratio, which you can get from this table. Again, I'm not going to do that in this video. That would give you the odds and odds ratio, give you an idea of the strength of a relationship. The other thing you can do is to report the whole set of statistics that help you to report the strength of linear association. So if we go back to descriptive stats and crosstabs, if we click on statistics here, can you see at nominal and then ordinal under each column you've got a whole load of boxes there. These are basically options to test for this, not to test, sorry, to indicate the strength of association, the degree of association. Are you weak or medium or strong between your two qualitative variables? Okay. Well, this is supposed to be a gentle intro, but I've said quite a bit towards the end. Finally, also, okay, so based on this test, it may appear there is a strong evidence between smoking and lung cancer. However, as with statistics, it's not always as simple as that, because although there could appear to be a relationship from the analysis we have done, this relationship could disappear when we introduce one or more other variable into the analysis, i.e. if we condition on one or more other variable. Sometimes this is called the third variable problem. So in correlation, the analogous thing in correlation to this is the partial correlation. So when you're looking at correlation between A and B, when you introduce C, the correlation between A and B could disappear. Disappear because A and B there's no real direct relationship between A and B. It's just that there appears to be a relationship between A and B because each of A and B are related via C. Okay, so similarly to here. But again, that's for another. Would be a bit more advanced than what we're doing today. So let's stop there. So in this video, just know that crosstabs is the test for the relationship between two qualitative variables, and that we use the chi-square test to do that. And the null is there is no relationship between two things A and B. The alternative is that there is a relationship between A and B. We look at the chi-square value. If we reject it, it means that there is evidence of a relationship, and then we go into the table of counts and report the percentages, look for a pattern there. Okay? Right, well, I hope that has been useful. Thanks for watching.